Have you ever looked at a plate of seafood and asked yourself, why do these shrimp and crabs turn orange when they are cooked? It is a perfectly logical question. These elites of the ocean bring in billions of dollars in revenue. They serve everything from humble, casual meals to the most extravagant banquet tables. They satisfy the taste buds of millions. But there is one thing that completely separates these billion-dollar creatures from the rest of the culinary world. When exposed to heat, crustaceans bloom into a brilliantly vibrant red-orange. Why do they, originally bearing the color of muddy moss at the bottom of the sea, hide such a scorching hot spectrum of color? What actually happens beneath that rigid shell when the water starts to boil? Today, we are going to decode the chemical mystery sitting right inside your kitchen, diving deep into a miraculous evolutionary mechanism that created this spectacular visual deception. To understand why your plate of seafood is a vibrant orange, we have to travel back to where they live, the quiet ocean floor. In the wild, shrimp, crabs, and other crustaceans are bottom-feeding creatures. Survival in the deep sea absolutely does not permit standing out. If they sported a blindingly bright orange color, they would instantly become a moving target, a perfect lunch for predatory birds or massive fish. Therefore, they need a flawless camouflage shell, usually gray, green, or muddy brown. This shell helps them sink seamlessly into the seabed environment. They evade predators with astonishing ingenuity. Take a prime example. Lobsters in North American waters typically cloak themselves in dark brown. Meanwhile, on the European coast, their shells might carry a signature blue hue. They blend perfectly into their surroundings, absolute invisibility. But here is the great optical illusion. The brilliant red-orange color you see on your dining table has actually always existed right inside the shell, from the very beginning. Everything stems from a natural pigment. Its name is astaxanthin. This is a pigment belonging to the carotenoid family. In fact, this is the exact same group of compounds that gives your familiar carrots their color. The true color inside a seafood shell is actually reddish-orange. It is all due to containing this astaxanthin pigment. So what exactly concealed that brilliance? And this is the part that surprises almost everyone. When shrimp and crabs are alive, the astaxanthin pigment is not free at all. It is tightly bound. Its jailer is a protein network. Its name is crustacyanin. This ingenious bondage literally bends physics. It completely alters the pigment's ability to absorb light. This chemical reaction blindfolds all of us. It forces the human eye to only see the reflected green, blue, or brown light. Put simply, the orange was already there, but it was locked down tight. A flawless seal by nature. Most of us, when standing in front of a steaming pot of seafood, think the fire is creating the red-orange color. Completely wrong. So what is actually happening inside your boiling pot of water? This drastic transformation only begins when the heat crosses the 80 degrees Celsius, 176 degrees Fahrenheit, mark. The protective crustacyanin protein network on the outside cannot withstand this level of thermal energy. They begin to denature. That sturdy protein structure instantly unravels. It is completely destroyed. The cage shatters. In that exact moment, the astaxanthin pigment is set free. Stripped of any binding, it immediately reflects its primal original red-orange light, a delicate biochemical reaction unfolding right before your eyes. In short, shrimp and crabs absolutely do not create an orange color when cooked. That terrifying heat is merely unmasking the inherent color that was hidden away. Their true nature is finally exposed. But here's the twist. Do you know about the ghost lobster? It is an exception. Not all shrimp and crabs turn red-orange when boiled. The occurrence rate of this albino lobster is 1 in 100 million, meaning 1 in 100 million. The cause is a genetic mutation. Their shells contain absolutely zero pigment. So even if they are boiled and served on a dining table, they still carry a pale, ghostly ashen white color. looking exactly like a phantom. And they are not alone. In the deepest, darkest trenches of the ocean, there is a kingdom of shrimp that refuses to change color. Deep on the ocean floor, hydrothermal vents exist. The temperatures here are brutally extreme, boiling violently. The temperature of the hot water vents at the bottom of the sea exceeds 400 degrees Celsius, 750 degrees Fahrenheit. The normal boiling point of water is just 100 degrees Celsius, 212 degrees Fahrenheit. Yet, the deep sea shrimp living here still do not turn red. Why is there such a bizarre paradox? In reality, they only live on the outer fringes of the vents. There, the temperature only fluctuates between 20 degrees Celsius and 60 degrees Celsius. This heat level is absolutely not enough to reach the 80 degrees Celsius threshold required to trigger protein breakdown. Furthermore, the ocean floor is completely devoid of sunlight, which means there is no algae. An algae is the primal source that creates astaxanthin. Therefore, the shrimp have absolutely no food source to supply this pigment. Over a long, drawn-out evolutionary process, they eliminated the pigment in their shells themselves. Their shells became thin and streamlined. This allows them to easily exchange nutrients with symbiotic bacteria. Let's head back to your kitchen, where everything unfolds much more clearly. The transformation doesn't just happen to the rigid outer shell. The shrimp meat also performs a magic trick of its own. When alive, shrimp meat is translucent with a slight grayish hue. Upon exposure to high heat, the protein structures in the muscle fibers unwind. Then, they clump tightly together. This protein denaturation scatters the light. It no longer allows light to pass through, forcing the shrimp meat to turn an opaque white. The heat also causes the shrimp's muscle bundles to react violently. They contract and curl up into a C shape. If severely overcooked, they will even curl into tight little marbles. Where do those faint pink streaks clinging to the cooked shrimp meat come from? They are actually from the pigment leaking out of the shell and seeping in. This is an absolutely fantastic culinary measuring tool. Chefs have a rule. Shrimp reach perfect and safe doneness when the thickest part of the meat hits the 145 degrees Fahrenheit mark. And here's a little-known truth. The protein denaturation mechanism that turns shrimp meat from translucent to opaque white isn't just triggered by heat. It can also be triggered by a highly acidic environment. Have you ever heard of the dish ceviche? People use acidic lime juice to cook fish and shrimp, denaturing proteins using acid instead of a literal flame. A genius culinary solution. But nature never wastes anything. The coloring agent for shrimp and crabs turns out to be a compound with incredibly high biological value. Astaxanthin isn't just for aesthetics. It is a literal biological shield, an ultra-powerful antioxidant. In shallow waters, the UV rays from the sun are absolutely brutal. This pigment helps protect the crustacean cells from UV destruction. But that isn't all. It is also a potent chemical weapon. The scientific community hypothesizes that accumulating massive amounts of astaxanthin in the shell also serves to repel barnacles, or prevent parasitic organisms from latching onto their shells. Just imagine it. Without this chemical defense, shrimp and crabs would be completely covered in parasites. They would lose their lives, or at the very least, humans could absolutely never consume their meat. It keeps the shrimp alive. And ironically, it also delivers spectacular benefits to humans. Eating the head, tail, or shell of the shrimp brings immense value. That is exactly where the astaxanthin is concentrated the most. It protects your immune system, fights off skin damage, and is excellent for cardiovascular health. And do you remember the bird that stole the color I just mentioned? That is the flamingo. The truth is, flamingos are born with naturally pale, ashen white feathers, stark white. But their diet consists primarily of shrimp, crustaceans, and algae. a source containing a colossal payload of astaxanthin and carotenoids. Thanks to this, their feathers gradually morph into a vibrant, brilliant pink. The only difference is, flamingos don't need to boil their food to extract the color. When they digest, the acids and fats in their stomachs take over this role. The acid literally dissolves the crustacean protein layer. The carotenoid pigments are set free and soak directly right into their downy feathers. Without this food source, a flamingo's feathers will turn pale and a sickly gray. It is a glaring sign of malnutrition or illness. So what about humans? Even if you devour a colossal mountain of shrimp, your skin will never turn orange. Although, this actually can happen if you eat way too many carrots loaded with beta-carotene. Now, look back at your banquet table. There is a paradox that goes completely against every single rule of cooking. The orange color change in shrimp and crabs when cooked is the exact polar opposite of red meat, like beef or pork. When you cook a piece of beef, a land animal, the meat shifts from a bright, vibrant red to a grayish brown. The discrepancy lies in the chemical composition. Red meat contains a protein called myoglobin. The very core of myoglobin contains an iron atom. When exposed to cooking temperatures, this iron radical oxidizes. It literally rusts, causing the color to dull into a brownish red. Conversely, white meats like young pork or chicken breast contain significantly lower levels of myoglobin, so they don't turn noticeably brown when cooked. Beef loses its red when cooked, but shrimp and crabs, they find their absolute brilliance the moment they touch the fire. Two entirely opposing principles. Why did nature mold such a deeply ironic mechanism? That dull, muddy gray shell you see sitting at the supermarket seafood counter. It isn't ugly at all. In reality, it is the proud cloak of the most resilient creatures on Earth. An indelible legacy of survival. And then, the truth finally emerges. Under the impact of searing heat, the imprisoning cage crumbles, the invisible armor vanishes, the primal orange explodes. That isn't merely the color of cooked food, it is the ultimate testament to a genius evolutionary secret that has flawlessly fulfilled its mission.